Algebra 2 Honors 9.4, Day 1. I'm going to split this into two parts. So part 1, we are going to relook at these special triangles, 30, 60, 90, and 45, 45, 90. And I am going to have you create it so the hypotenuse is of length 1. And then we are going to be drawing triangles where the hypotenuse is of length 1. And so to do that, we're going to need to get the hypotenuse to be 1. And so in the 30, 60, 90, if I divide each side by 2, then I get a hypotenuse of 1. And the short leg is now 1/2. And the long leg is √3/2. And that will still fit the ratios needed for a 30, 60, 90 triangle. In the 45, 45, 90, to get the hypotenuse to be 1, I need to divide by √2. So I'm going to divide each of the sides by √2. And 1 over √2 rationalized is √2/2. So on the 45, 45, 90 triangle, to get the hypotenuse to be 1, the two legs are going to be √2/2 and √2/2. So now I want you to draw the triangle but make the hypotenuse 1. So I want you to be using these two triangles. Let's try that in example A here. Find the exact values. This is all no calculator. Do not use a calculator. Do not. You need to just know how to do this. And it takes work up front to get there. So draw a triangle where possible. You might not get a reference angle of 30, 60, or 45. It might be one of those quadrantal angles, and then you don't draw a triangle, and we'll see that when we get to it. All right, so sine of pi thirds. Well, draw the triangle. That angle is going to rotate up and be pi thirds right there, and pick a point on that terminal side, drop, and create a right triangle. But now I want the hypotenuse to be 1. And when the hypotenuse is 1, then opposite the short, or the pi 6, which is the short leg, is going to be right here. That's going to be your 1/2. And opposite the pi thirds is your long leg, and that value is √3/2. Those are the values you use now when the hypotenuse is 1. So this ordered pair is 1/2, √3/2. And sine is y/r. Well, my y value is √3/2, and my r value is 1. So that just simplifies to √3/2. When you are on the unit circle, your sine value is just the y coordinate of that point on the terminal side. That's unit circle is when your hypotenuse is 1. For secant of pi fourths, well, if I go and draw a 45 degree, a pi fourths angle, so that's rotating pi fourths, pick a point on the terminal side, drop a right angle. Well, on the 45, 45, 90, the hypotenuse is 1, then the legs are √2/2 in both cases. So the ordered pair here is √2/2, √2/2. And the secant is the reciprocal of cosine, so that is r/x. The r is 1, and the x value is this √2/2. Well, if I take 1 and divide it by √2/2, you get the reciprocal. You get 2/√2, and then rationalize. You get 2√2/2, which simplifies to just √2. For tangent of pi 6, well, the pi 6 is going to look something like this when I draw that angle. It's at 30 degrees. If it's in degrees, drop. Always drop to the x-axis, never to the y-axis. And the hypotenuse is going to be 1. Then this leg is your long leg, and you go up the short leg at value of 1/2. And so this point, you're going long to the right and up the short leg value, up 1/2. Those are your ordered pairs. And so tangent is defined to be y/x, and you get a 1/2 over √3/2. And if you multiply 1/2 by the reciprocal, 2 over root 3, that becomes 1 over root 3, or those just cancel when they're the same. You're multiplying by the reciprocal, they end up canceling, you get 1 over root 3. And if you rationalize that, you get root 3 over 3. And that's your tangent of pi 6. So that's the work I want to see on the worksheet that you're going to be doing. I want you to draw triangles in the correct quadrants where the hypotenuse is 1 using these new triangles. So let's look at this with 135 degrees. And 135 degrees is going to rotate around, and it's going to be 45 degrees short of 180. So your reference angle is that 45 degrees. Pick a point on the terminal side, draw a triangle. The hypotenuse I want to be 1. So the 45, 45, this is to the left, negative root 2 over 2, and up root 2 over 2. So this ordered pair in quadrant 2, the x is negative, the y is positive. Remember, all students take calculus. Sine, therefore cosecant, are positive in quadrant 2. All the others are going to be negative. Cotangent is x over y. It's that negative root 2 over 2 all over root 2 over 2. And so the x and y have the same absolute values. It reduces to a negative 1. Cosine of 300 degrees. That's 60 degrees short of a full rotation, so we end up over here with a 60-degree reference angle. Pick a point on the terminal side, and we always go to the x-axis, never to the y-axis. So there's that. And so we go to the right, the short value of 1/2, and down the long leg value of negative root 3 over 2. So the ordered pair would be a positive 1/2 and a negative root 3 over 2. And cosine is x over r, which is your 1/2 all over 1 because your radius is 1, and you get 1/2. When you are on the unit circle, when that radius is 1, the hypotenuse is 1, the cosine of that angle is going to be just that x coordinate. Then we have tangent to 270. Well, 270 rotates around and it ends on an axis. And so that's one of those quadrantal angles. So we think of being on a unit circle, this point would be 0, negative 1. So x is 0, y is negative 1, and we're on the unit circle. R is always positive, r is 1. Tangent is defined to be y over x, which is going to be negative 1 over 0, and that is not possible. It is undefined. I don't put equals, or at least I'm going to try not to, because it's not really anything to be equal to, because it's undefined. Just UND for undefined and box it. So that's changing things up, but we're leaning towards using triangles with hypotenuse 1 to lead us into what we call the unit circle. And so learning the unit circle, x squared plus y squared equals 1. What we want to be able to do is think about triangles, and they're either your 30, 60, 90 or 45, 45, 90, to just be able to write down the ordered pairs where the terminal side hits that unit circle. And so we're going to start with just a 30-degree angle here. And basically, we're going to draw the triangle, so drop to the x-axis, and label using hypotenuse is 1. To the right would be the long leg, up would be the short leg. And so this ordered pair, you're going to the right, the long leg value, and up the short leg value. So that's that ordered pair. And so the sine of 30 degrees is that y over r, which is 1/2 over 1, which is just 1/2. Again, when you're on the unit circle, the sine of the value is the y coordinate of the point on the unit circle where the terminal side intersects it. So that's 1/2. The cosine of pi 6, which is your 30 degrees, is your x over r. It is your root 3 over 2 over 1 because the radius is 1 and r is always going to be positive. And you get root 3 over 2. And when you're on the unit circle, the cosine value is always your x-coordinate of the point on the unit circle. And then tangent is your y over your x, which is your 1/2 over your root 3 over 2. So you end up multiplying by 2 over root 3. The 2's cancel. You get 1 over root 3 rationalized. That's root 3 over 3. And so what we want to do is we want to be able to see that triangle where this is your 30 degrees and set up this is 1, this leg is root 3 over 2, and this is 1/2, and know that this ordered pair is root 3 over 2 up 1/2 by just seeing that triangle and understanding the value of the long leg and the short leg when the hypotenuse is 1. And now, once I have that ordered pair, the idea is that the sine of 30 degrees is the y-coordinate, and the cosine of the 30 degrees is the x-coordinate, as long as those are the ordered pairs on the unit circle. And then tangent is your y over x. It's actually because tangent's your sine value over your cosine value. And that's where we got that to be root 3 over 3. So tangent, you still need to do the y over x. But sine and cosine can actually go a little faster. All right, so let's go ahead and look at the 45 degree. And so if I go 45 degrees, and where that terminal side hits the unit circle, drop a right angle, and then have the hypotenuse be 1. This is root 2 over 2. This is up root 2 over 2. So this ordered pair is to the right root 2 over 2 and up root 2 over 2. And so your sine of 45 degrees, again, is your y over r, which is your root 2 over 2 over 1, or just the y value, root 2 over 2. Your cosine is your x over r, which your x is root 2 over 2, all over radius of 1, which is just your x value. And that's the kind of nice thing. Sine and cosine of 45 degrees, or pi 4, are both root 2 over 2. And then your tangent is your y over your x. And in this case, they have exactly the same value and the same sign. And so it comes out to a nice clean 1. So when I'm looking at 45 degrees, I'm going to come to this ordered pair. And remember, for 45 degrees, that's root 2 over 2 to the right and root 2 over 2 up in the triangle. And that's that ordered pair. And then I can use the definitions of sine is your y value, cosine is your x, tangent's y over x, and all the reciprocal functions. When on the unit circle, sine of theta is y, cosine of theta is x, and then tangent is your y over x. All right, and then we have the 60, which just orientates that 30, 60, 90 a little different. So this is your 60 degree. Drop an altitude to the x-axis, hypotenuse is 1. Then to the right is 1/2, and up is your long leg of root 3 over 2. So you're going short to the right of 1/2 and up the long value of root 3 over 2. And so the sine of 60 degrees is your y over your r. It is your root 3 over 2 over 1, which is just going to be the y value at that point. The cosine is x over r, which is 1/2 over 1, which is then just the x value of that ordered pair. And tangent of 60 degrees is your y over your x. It is root 3 over 2 over 1/2. And if you take root 3 over 2 and multiply by the reciprocal, 2 over 1, the 2's cancel, and you end up with just root 3. and that's your tangent of 60 degrees. So again, 60 degrees, you're going, if I just kind of see it, I'm going the short leg to the right and the long way up. So it's going to be 1/2, and then the long leg up is root 3 over 2 to get that ordered pair. Unlike when I did the 30-degree triangle, I went the long leg to the right, which is root 3 over 2, and the short leg up, which is 1/2. So I can kind of visualize that and remember what the order is of how to use root 3 over 2 and 1/2. All right, and then we still have quadrantal angles. We have 0 degrees, which is 0 radians, and this is the unit circle where that unit circle hits the terminal side. We are going to be to the right one and up 0. Up at 90 degrees, or pi halves, we're going to be not going to the right or left any, but we're going to go up 1. So we've got the ordered pair 0, 1. I'm going to rewrite that. And so if I'm at one of those quadrantal angles, sine of 0, well, at 0, the y-coordinate is 0. Sine of 90, well, the y-coordinate at 90 is 1. Cosine of 90 degrees, the x-coordinate of 90 degrees is 0. And tangent of 0, I need to do y over x. And at 0 degrees, the y is 0, the x is 1, and that simplifies to 0, and you need to write it as 0. So you got to remember, at quadrantal angles, we don't draw triangles, but we use the ordered pair where the terminal side hits the unit circle. So they're going to be 1, 0, 0, 1, negative 1, 0, or 0, negative 1, depending on which axis you're on. All right, so, well, this whole unit circle goes into all the other quadrants. And we're going to be using these same values of 1/2 and root 3 over 2 and root 2 over 2, but it's a matter of which ones are positive, which ones are negative, and knowing all the different angles in degrees and radians. And so cosine of 120 degrees, for quadrant 2, you'd be rotating around to 120 degrees, which you would get a 60-degree reference angle. And so the hypotenuse is 1. This will be short leg to the left, negative 1/2, and up root 3 over 2. So this ordered pair is negative 1/2 up root 3 over 2. In quadrant 2, all your x-coordinates are negative, your y's are positive. And so over on this diagram here, we have, if this is 120 degrees, that's going to be the same as 2 sets of pi thirds. And that ordered pair on the unit circle, I'm just thinking you're going short leg to the left and long leg up, kind of seeing that triangle. It's going to be a negative 1/2 and up root 3 over 2. And so the cosine of 120 degrees, it's your x over r, which is your negative 1/2 over 1. It is just going to be negative 1/2. It is the x-coordinate of the point at 120 degrees on the unit circle. And then we could do the other 6 trig functions, but just that's a little start on that one. Then if we have and swing 3 pi fourths, 135 degrees. So this angle is 3 sets of pi fourths, 3 sets of 45 degrees. That leaves my reference angle of pi fourths, where the terminal side hits the unit circle. If I drop an altitude always to the x-axis, hypotenuse of 1, this is going to be left root 2 over 2 and up root 2 over 2. So this ordered pair is negative root 2 over 2 and up root 2 over 2. And so the sine is your y over r, which is positive root 2 over 2 over 1. It is just root 2 over 2. It is the y-coordinate of the point that hits that unit circle at 135 or 4 degrees or 3 pi fourths radians. And so over on this diagram, we have 135 degrees. is the same as 3 pi over fourths in radians, and that ordered pair that we're going to use there is negative root 2 over 2 and up root 2 over 2. Remember that all students take calculus, sine, and therefore its reciprocal function, cosecant, are the only two that are positive in quadrant 2. The other 4 are going to all be negative. So cotangent of 150 degrees. So again, we rotate 150 degrees. That's going to leave a 30-degree reference angle. And we drop an altitude. So if I go to the left, I'm going the long leg value of negative root 3 over 2, and I'm going up the short value of 1/2. So that ordered pair is negative root 3 over 2 and up 1/2, where the hypotenuse is 1. And cotangent is x over y. So we have a negative root 3 over 2 all over 1/2. And if you take negative root 3 over 2 and multiply by the reciprocal 2 over 1, the 2's cancel, and you get negative root 3 for that value. That's your cotangent of 150 degrees. All right, and so over here on the diagram, we have 150 degrees. And that's going to be 5 sets of 30 degrees. It is 5 sets of pi 6 for radians. And that ordered pair is the left, negative root 3 over 2 and up 1/2. And up 1/2. And so sine of 150 degrees is the y coordinate, 1/2. Cosine of 150 degrees is the x coordinate, negative root 3 over 2. Tangent would be y over x, and you'd end up getting negative root 3 over 3 when you rationalize. Well, we also have to remember our quadrantal. We've already seen at 90 degrees, that's the same as pi halves, and that ordered pair is 0, 1. And at 180 degrees, that is going to be pi in radians. That ordered pair is negative 1, 0. So tangent of 90, look up at the 90 degrees, use the y over the x, is 1 over 0, and that is undefined. Tangent of 180, you need to switch to the negative 1, 0, and look at that ordered pair, and there the y is 0 while the x is negative 1, and 0 divided by negative 1 is 0. Cosine of 180 degrees is your x over r, which is a negative 1 over 1, which is just negative 1. Again, it's going to be just the x coordinate there. So there's your quadrant 2. And so using the definitions x, y, r for the 6 trig functions and these ordered pairs, you can get the values of the trig functions. So on your homework, I'm going to want you to draw these triangles for right now, for each problem, and with the hypotenuse of 1, and show me how you're using the definition. Show me that it's y over x or x over y or y over r, and plugging in values and showing me how you're coming to the answer, not just answers. So then move to quadrant 3. And in quadrant 3, if we draw the triangles at 210 degrees, this is a 30 degree. This is going to be negative root 3 over 2 and down 1/2. Both x and y are negative, so negative root 3 over 2 down 1/2. So that's a 210 degree rotation, 30 degrees beyond pi, so it is a 7 pi 6 in radian, and that ordered pair is going to left the long leg value and down the short leg value. So tangent is going to be y over x. It's going to be a negative 1/2 over a negative root 3 over 2. The 2's would cancel, so you get this 1 over root 3. Negative divided by negative is positive. Rationalize, you get a positive root 3 over 3. Remember that all students take calculus. Tangent and therefore cotangent are positive in quadrant 3. The other 4 trig functions will be negative. Cosecant of 225 degrees. If we go 225 degrees, you have gone 45 degrees beyond 180. So you've got to the left root 2 over 2, down root 2 over 2. The ordered pair is negative root 2 over 2, negative root 2 over 2. And cosecant is your reciprocal of sine, so it is your r over your y, or 1 over the y value of negative root 2 over 2. And so you end up flipping that, getting a negative 2 over root 2. And when you rationalize that, you get a negative 2 root 2 over 2, which is a negative root 2. There we go. So negative root 2. So over on the bigger diagram, that's 15 degrees beyond 210. It is 225 degrees. And that's 45 degrees beyond pi, so it is a 5 pi fourths. And that ordered pair is to the left root 2 over 2 and down root 2 over 2. Then for 4 pi thirds, you end up pi thirds beyond pi. That's 60 degrees in terms of reference angle and degrees. And I forgot to put 1 on the hypotenuse on the other. So this is a 1 for the hypotenuse. You're going left the short leg value and down the long leg value. So it's negative 1/2 and down root 3 over 2. And so cosine is going to be x over r, which is your negative 1/2 over 1. And again, for cosine, it ends up just being the x coordinate on that unit circle. So over here, we're 60 degrees beyond 180. We are 240 degrees. And that is going to be 4 sets of pi third. 4 times 6 is 240. 60 is 240. And so this ordered pair, again, I'm just going to the left the short amount and down the longer amount from 0, 0. And there's your ordered pair. Then we also still have our quadrantal angles, 180 degrees and pi radians, negative 1, 0. And right here we have the point 0, negative 1, and that goes with 270 degrees, or 3 sets of 90, 3 pi halves. And so sine of pi, we want to go to where we have pi, and it's the y coordinate. It's 0. Sine of 3 pi halves, go down to the 270, and the y coordinate there is negative 1. And cosine of 3 pi halves, it's the x coordinate at 270, it is 0. When you're on the unit circle, that's how you can get those values. All right, and then the fourth quadrant. And so if we go to 300 degrees, that leaves a 60 degree. We draw the triangle. We're going to the right 1/2, down root 3 over 2, where the hypotenuse is 1. This point is to the right the short amount, down the long amount, negative root 3 over 2. And the secant is the reciprocal of cosine. So it is r over x. It is 1 over 1/2, which is 2. So right here we have 300 degrees, which is 5 pi, oops, not over 6, 5 pi thirds, 5 pi thirds there. And that point right there is to the right 1/2 and down the long leg amount of negative root 3 over 2. For 7 pi fourths, you are pi fourths short of a full rotation. Your reference angle would be pi fourths. The legs are going to be root 2 over 2 and negative root 2 over 2. As you go down, hypotenuse of 1, the ordered pair is right root 2 over 2, down negative root 2 over 2. And the sign is just your y coordinate there. Of course, it's y over r, which is negative root 2 over 2, but the radius is 1. And so it's negative root 2 over 2. So at that 45-degree reference, you're to the right root 2 over 2 and down negative root 2 over 2. And that is 315 degrees, or it is 7 pi fourths, 1 pi fourth short of a full rotation. And cotangent of 11 pi 6, that's going to make your reference angle pi 6, 30 degrees. You're going to go the long leg to the right, and your short leg down, so that's positive root 3 over 2, but down 1/2. We should be checking. Your x coordinates are all positive in quadrant 4, your y coordinates are going to be negative. And then cotangent is x over y. So it's root 3 over 2 over negative 1/2. If you multiply by that negative 2 over 1, the 2's will cancel. You end up with a negative root 3. And then we have our quadrantal angles. Again, you have your 270 degrees, which is 3 sets of pi half. And that ordered pair is 0, negative 1. Or we're down a full rotation of 360 degrees, or 2 pi radians, which is the same as 0 degrees and 0 radians. And that's to the right 1, 0. And we need to use those for cotangent of 3 pi halves is x over y, which is 0 over negative 1, which is 0. Tangent of the 270 degrees is y over x, which is negative 1 over 0, which we can't do, so tangent is undefined. And cosine of 2 pi, well, it's just your x coordinate at 2 pi, and it is 1. It's x over r, it's 1 over 1, and it is just 1. So there you have it. This is what I want you to do on your homework. I want you drawing the triangles and showing me the definitions and substituting in values. Show me that you know how you arrive at your answer, not just having final answers with no work.